There are dates that pass through your life like background noise, and then there are dates that begin to feel like they're watching you back. Long before you reach them, they lean in. They wait. December 19th, on every normal calendar you've ever used, is just another winter day. A square of ink. A number between others. You could oversleep, rush to work, check your notifications, complain about the weather, and nothing around you would whisper that anything is different. But far above your ceiling, above the office lights and traffic and clouds, there is another kind of calendar quietly keeping score. It lives inside orbital simulations, inside telescope schedules, inside code that traces the paths of cold things moving through a colder dark. On that calendar, December 19th is no longer neutral. It has begun to glow in a shade you don't have a word for. It repeats. It returns. It refuses to sit down. In those quiet windows of code and graphs, December 19th is not circled by panic, or by prophecy, or by red exclamation marks. It is circled by a question. It is the day when a small interstellar comet named 3I/Atlas will be seen from Earth in a certain way, at a certain angle, against a certain patch of stars. It is the day when patterns that have been glitching at the edge of our understanding will either sharpen into something undeniable, or dissolve back into noise. It is the day when people who study the universe for a living, people who are trained to distrust drama, quietly disagree about what the universe is about to say. Some of them expect nothing. Some expect a whisper. A few, in their most unguarded moments, admit they're hoping for something like a confession. You, listening to this, inhabit the soft interior of that date. You will feel the air on your face, not the thin vacuum above it. You will see the ceiling of your room, not the ceiling of the sky. You will feel only the familiar weight of gravity on your body, not the faint extra pulls that might be shaping the paths of things you will never see. On December 19th, all of that will seem the same. The unsettling part isn't that your day will be different. The unsettling part is that above you, the universe may be quietly deciding whether to reveal that your picture of normal has been incomplete all along. When 3I/Atlas first appeared in that picture, it did not walk in like a main character. It entered like a smudge, a faint, stretched whisper of light, barely above the noise floor of a deep survey exposure, sliding slowly against a background of patient stars. A detection algorithm flagged it with a label that has become increasingly familiar over the past decade: possible interstellar. That phrase alone is enough to make telescopes swivel. Objects like this do not belong to our sun. They are not born in our planetary nursery. They are passing through debris from other systems, other histories, other gravitational conversations that we were never part of. The routine unfolded as it always does. Automated alerts went out. A handful of observatories pointed their mirrors toward the coordinates. Follow-up images confirmed motion. Yes, this smudge was drifting in a way that did not match the slow march of distant stars. Early reports were comfortingly plain. No dramatic jets bursting into existence. No bizarre color signatures in the spectrum. Motion, mostly as expected for an object on a broad interstellar trajectory. Brightness, modest, rising and falling in ways that look textbook clean. Somewhere, someone wrote up a short notice. 3I/Atlas, likely interstellar comet, unremarkable activity so far. It was the kind of discovery that, in another year, would have generated a week of quiet excitement and then dissolved into the background churn of work. But hidden in those first nights of numbers, in the columns that tired eyes skimmed and then moved past, a few values refused to sit exactly where they were told. A predicted position that was off by a hair. A brightness that, on one night, was a little higher than the model said it should be, and on another, a little lower. Not enough to ring alarm bells. Just enough to make someone type, almost as a throwaway note, "Odd, recheck later." The same thing, the train thing, was to shrug and move on. Early data is messy, comets are messy, everything interesting is allowed to be a little wrong at first. Quietly though, more than one person added a second annotation. Compare again near Dec 19th. Comets, when they decide to behave, are an ode to obedience. Gravity draws them in, sunlight heats them, ice turns to gas and drags dust into space, and all of that chaos, averaged over time, produces paths we can draw with terrifying precision. Give an orbit enough data points and it will tighten like a pulled string. For the first weeks, 3I/Atlas seemed happy to play this role. Astronomers took their newly measured positions, fed them into software that speaks fluently in Newton and Einstein, and watched the emerging arc bend smoothly through the solar system. In from the dark, a distant swing past the sun, and then away again, never to return. It was a story they knew. Then the data deepened. More observatories joined. Nights piled on nights. Each new measurement was another chance for the orbit to refine itself, to settle into the neat line where prediction and reality meet. Instead, something subtle began to happen. The line twitched. The fit improved in some places but grew worse in others. Correct for the usual suspects. Outgassing jets pushing the comet like tiny thrusters, irregular shapes making it spin uneven. Correct for solar radiation pressure nudging the dust. Correct for slight biases in each instrument, for atmospheric quirks, for the fact that nothing in the universe is ever perfectly clean.
They don't match
A residue
the standard model
remained,
at all.
small, quiet, coherent. When they plotted those residuals, the differences between where 3I/Atlas should have been and where it actually was, something else appeared. The errors were not randomly scattered. They leaned, ever so slightly, in a consistent direction during certain parts of the orbit. And the place where that pattern became sharpest, where the residuals stacked on top of each other like tiny arrows all pointing the same way, fell on a segment of the comet's path that would line up with Earth's vantage point, around December 19th. Light, in theory, is the part that should be easier. When a comet drops inward, sunlight works its fingers into ancient ice. Gas vents from fractures. Dust is freed from surfaces that have been frozen for millions of years, and the coma, the fuzzy atmosphere around the nucleus, swells. The brightness of the object rises in a way scientists can model almost like a heartbeat. For a while, Atlas complied. It brightened as it should. Pixel counts marched upward. Amateur sky charts updated to say, visible under dark skies with binoculars. For a brief stretch of time, this smudge from another star became a tiny, fragile ornament hung on our sky. Then, as always, the curve turned. The comet passed its closest approach, its ice supply dwindled, and its light should have begun a smooth, graceful decline. Instead, the descent stuttered. Instead of a single downward slope, analysts saw tiny terraces, brief plateaus where the brightness held steady when it ought to be falling, gentle bumps where it rose back up a notch before dropping again. On some plots, the effect was barely visible, a soft jitter in the noise. On others, where the data was cleaner, the atmosphere steadier, the instruments sharper, the pattern looked uncannily like a pulse. A shallow, repeating lift and fall, too subtle to see with the human eye in the raw images, but persistent in the numbers. The first explanations were familiar. Rotation. As the comet spins, bright jets rotate in and out of view, producing periodic flickers. Internal fractures. Regions of fresh ice exposed at different times. Both of those could be true, and probably were, to some degree. But the timing did not quite align. The spacing between the pulses refused to match any plausible rotation period, no matter how they twisted the models. The symmetry of the pattern was off for simple jet scenarios. Once again, the oddity was not loud, it was quietly precise. The more they cleaned the data, the more it felt as if something outside the comet was gently, rhythmically tightening and loosening a grip that only the comet could feel. Tightening into December 19th, loosening after. If you watch a comet long enough, its tail changes from decoration into record keeping. Early images of 3I/Atlas showed what the public expects. A delicate plume pointing away from the sun, a stream of dust and gas caught in the push of photons and solar wind. From a distance, it looked like the classic chalk stroke across black velvet that you see in books. Up close, inside the numerical grids, it looked as messy as any real system should. Turbulent flows, asymmetric jets, microscopic grains drifting at different speeds. Beautiful chaos. Then the teams did what they always do when they suspect a pattern might be hiding just below the surface. They stacked images, hours of exposure, nights of observation, aligned, averaged, filtered. In those deeper views, the haze thinned and structure emerged. Down the length of the tail, faint bands appeared. Not dramatic, not like the crisp rings of Saturn or the sharp edges of a shock wave, but softer, ghost-like ripples. If you squinted at the data, they looked like the concentric waves spreading outward when a stone disturbs a perfectly still lake. The spacing between them wasn't exact, but it was regular enough that no one was comfortable calling it an illusion. Solar wind models were stretched and twisted to fit the new evidence. Could streams of charged particles changing speed and direction produce those shell-like features? Could variations in the sun's magnetic field sculpt the dust into rings? Some of that worked, almost. Yet the timing of the ripples, their spacing, and their alignment with the comet's orbit remained annoyingly resistant to a clean explanation. At late stages, the nucleus's own activity was weak. Its jets, if any remained, were too feeble to carve well-organized patterns down the tail. The simpler picture, the one people were reluctant to say out loud at first, was that the dust was being pulled, not just by the sun but by something else traveling nearby. Something massive enough to leave a repeating fingerprint in the wake, and yet invisible as an object in its own right. When you suspect something is there but cannot see it, you stop staring at the thing that's glowing and start staring at the things behind it. With Atlas, that meant treating every image as more than a comet portrait. It meant treating it as a lattice of distant stars, perfectly placed reference points scattered far beyond the drama in the foreground. The question became brutally simple. Do those background stars sit exactly where they're supposed to sit? 4 long stretches of 3I/Atlas's journey, the answer was a soothing yes. Within the expected blur of atmospheric turbulence and instrumental error, the starfield held its grid. Pixel coordinates danced within their uncertainties, but there was no hidden hand pushing them. Then, as the comet moved across a certain region of sky, one that, not coincidentally, overlapped the dates around our now familiar winter day, something shifted. When the images from those nights were layered, aligned, and subtracted, a tiny distortion appeared. Not in the comet. In the background. A handful of stars in one small patch seemed displaced by a whisper. Their positions wobbled by a fraction of an arcsecond. Just enough that software not told where to look flagged the same region in separate datasets. Before that window, the pattern was straight. After it, straight again. During those frames, the universe's grid looked like it had inhaled, held its breath for a moment, and then exhaled. Gravitational lensing on that scale is usually the domain of giants. Galaxies bending the light of even more distant galaxies, clusters warping space like heavy balls on a rubber sheet. Seeing a faint cousin of that effect near a comet, even as a suggestion, is the kind of thing that makes people go very quiet in meetings. Was this real? An artifact? A glitch in alignment? A quirk of refraction? The uncomfortable part was not that one team saw it. It was that independent teams, with different instruments and different pipelines, all found their attention pulled toward the same tiny bruise in the starfield. No one could yet say what passed between us and those distant suns in that brief interval. They could only say that something had, or that the universe wanted very badly to pretend it had. To make sense of motion, you cannot only look forward, you must fold time back on itself. So they took the evolving orbit of 3I/Atlas and rewound it. They treated the solar system like a film running backward, planets retracing their arcs, the comet reversing through space, frame by calculated frame. Where would Atlas have been years before anyone noticed it? Which survey telescopes, sweeping the sky for other things, might have accidentally captured it as an anonymous speck? In archives filled with anonymous specks, they found hints, faint dots on old images that, when stitched together, could plausibly be the earlier steps of 3I/Atlas or of a similar interstellar wanderer. The point was not to pin down exact identity, the data was too thin for that, but to look for a pattern in the misfits. And there, again, something familiar emerged. The small deviations, the tiny ways objects refused to align perfectly with their supposed paths, seemed to cluster around certain geometric configurations, particular arrangements of sun, earth, and traveler. Particular alignments where our line of sight intersected not just the object, but the same region of space through which it was moving. December 19th in the current orbit was one of those alignments. It sat on the diagram like a repeated note in a melody you'd half forgotten, now playing again in a slightly different key. It began to feel less like random chance and more like choreography, as though some unseen structure, or structures, had chosen long ago the configurations in which it could be most easily betrayed by its own influence. Not everyone followed that thought willingly. In offices where the lights stay harsh and the coffee stays bitter, another kind of conversation held its ground. Comets misbehave all the time, the skeptic said. That is their nature. They are lumpy, volatile, and poorly understood. Outgassing can mimic gravitational anomalies more easily than gravity can mimic outgassing. Image processing can conjure rings where there are only gradients. Starfields can appear to twitch when the atmosphere above a telescope decides to play a trick, or when a detector's response shifts by a fraction. Statistical flukes, they reminded everyone, are not just possible. They are inevitable when you stare at enough data for long enough. To these voices, December 19th was not a date chosen by the universe. It was chosen by us. We circled it because we saw a few interesting anomalies there, and then we started looking for more. The circle created the story, not the other way around. They warned against cosmic pareidolia, against drawing faces and meaning into the clouds of numbers because we crave pattern more than we crave precision. And yet, even as they cautioned, many of them quietly adjusted their schedules. Even as they argued that nothing special would happen, they submitted telescope proposals that said, in more careful language, we should be watching anyway. After all, they said, even a null result is a result. Even if nothing happens, one of them admitted into a microphone, the questions this comet is forcing us to ask are worth the time. On the other side of the divide, a different group watched the same data and felt something like a rare window opening. They took the stubborn residuals in Atlas's orbit, the fragile rings in its tail, the barely there starfield shift, and they fed them into universes built of math. In those simulations, unseen objects, tiny black remnants left over from violent cosmic births, exotic compact masses that no longer shine, drifted alongside comets like hunters shadowing their prey. They tuned the mass, the distance, the trajectory. And in some of those simulated realities, when Earth, Atlas, and the lurking companion slipped into certain alignments, the outputs looked eerily familiar. Orbits that drifted just so, tails that developed faint concentric structures, background stars that slid by a tiny but coherent amount. For them, December 19th was not the day the companion would suddenly do something new. It was the day we would finally stand in exactly the right place to see what it was already doing. If the universe is riddled with compact objects that have gone dark, they argued, black seeds wandering between stars, too small to light up their surroundings and too massive to ignore, then we need nights like this. Nights when a fragile piece of ice happens to be tethered to one of them in just the right way to betray its presence. If they were right, the question, what will happen, was the wrong tense. The real question was, will we finally catch up to what has been happening for a very long time? A third camp shifted the focus further away from objects and toward the stage itself. They looked at Atlas not as a comet with a hidden partner, but as a test mass crossing a bruise. In their minds, spacetime was not an endlessly smooth, forgiving fabric. It was something that could be scarred. Long before our system coalesced from gas and dust, something violent might have passed through this region. A small black hole, a topological defect, some relic of the early universe's strange physics. The passage could have left behind a local warp, a subtle curvature that never fully relaxed. Space in that region would not be dramatically twisted, not enough to tear stars apart, but just enough to give delicate objects a tiny, consistent nudge. In their models, Atlas's path dipped as it crossed this invisible hollow. Its tail curved in response to gradients that no diagrams currently show. Its interior flexed, ever so slightly as the stress field changed. When Earth, the comet, and that warped region aligned, the effects on light from distant stars became just noticeable enough for our instruments to register. December 19th then was not a date when something new arrives, but a date when three pre-existing things, Earth, comet, scar, share a geometrical whisper. For them, the haunting possibility was not that there was a hidden object nearby. It was that the space we think of as blank might actually be holding on to the memories of events no living thing ever saw. And then there were the dark matter architects, people who have spent entire careers thinking about invisible mass on scales that dwarf our planetary worries. In their day jobs, they simulate galaxy clusters, map the unseen halos that cradle spirals of stars, and try to understand how something that does not emit light can still choreograph such luminous beauty. Looking at 3I/Atlas, some of them wondered whether the same dark substance that shapes galaxies might also leave smaller fingerprints in our own backyard. In their mental picture, threads or clumps of dark matter drift through the outskirts of the solar system like cold, weightless fog. You cannot breathe it. You cannot see it. But inside that fog, gravity ceases to be what you thought it was, in small, consistent ways. Comets like Atlas, light and brittle, would be excellent test particles. Cross a filament and your orbit would bias. Your tail would warp. Your nucleus would feel a strain it was not built to endure. The moment you slipped out of the denser region into thinner surroundings, you would relax, shedding that tension in dust and light. In that story, December 19th marks Atlas crossing a boundary. Inside the filament before that date, it has been quietly affected in ways we are only now noticing. At the edge, around the time we will be watching most intently, its behavior might change just enough to mark the transition. Not in a way that lights up the sky, but in a way that scribbles here on our maps of the unseen. If they are right, what will really happen on December 19th is that, for a few hours, a frozen traveler from another star will trace with its fading tail the contour of a structure that has been helping hold our galaxy together for billions of years. Across all these possibilities, black seeds, scars, halos, frustration gathers in the same corners of the room. No single picture fits every anomaly. The compact object model does a beautiful job of matching the orbital residuals, but tends to underpredict the extent and timing of the tail ripples. The dark matter filament scenario explains the idea of a boundary crossing and the subtle brightness pulses, but struggles to produce a starfield distortion as sharp as the one some teams think they've seen. The scarred spacetime concept can reproduce the lensing-like effect and the overall path deviation, but fights with the exact phasing of the light curve tremors. Graph after graph shows lines that almost lie on top of each other, then peel away by just enough to matter. Parameters are tuned, retuned, and tuned again. Networks of computers explore thousands of tiny changes to inputs, creating a forest of possible universes, each with its own atlas. Some universes match the orbit, some match the tail, some match the stars. None yet satisfy every constraint at once. Standing in the glow of all that simulation, you get the sense that reality is letting us trace its outline with one fingertip, but refuses to let us close our hand around it. Meanwhile, something softer is happening underneath the noise of equations and debates. In observatories perched on mountain ridges, on volcanic summits, in dry desert air, December 19th has quietly migrated from just another line in a shared scheduling spreadsheet to a point of convergence. Observation blocks are shifted. Time that was once earmarked for other targets is gently reclaimed. Just in case, people say, trying to keep their voices neutral. Backup systems are tested. Drives are scrubbed. Data pipelines are hammered with synthetic workloads to see where they might break. No one prints posters. No one writes "the night" in capital letters on their calendars. Many of these scientists do not believe anything unusual will happen in the cinematic sense. And yet, their collective behavior tells another story. Whether the universe whispers that night or remains stubbornly quiet, they have decided to be listening as carefully as they possibly can. If you could step outside your own life and sit in every one of those rooms at once, the night of December 19th would unfold like a slow, synchronized breath. On one side of the planet, the comet will rise in the hour before dawn, so faint that no unaided eye will ever notice it, a ghost smudge in a sky already washed with the first hint of morning. Somewhere else, on a different continent, the same object will be sinking into evening twilight, barely above the horizon, lost to anyone who doesn't know exactly where to point. Telescopes will move with quiet, mechanical grace. Domes will split open, letting in air that smells of frost and metal and dust. Control rooms will glow in dim red and blue. Screens will begin to populate with lines of fresh numbers. Timestamps, exposure times, counts, signal-to-noise ratios. Automated scripts will light up graphs as the data comes in, comparing each new point to models that have been rehearsed for months. Human eyes will track those lines with a focus that has very little to do with spectacle. For most of the 8 billion people on Earth, this night will be indistinguishable from the ones before and after it. For a tiny fraction of them, it will feel like standing in a dark hallway holding your breath, listening for a footstep you might never hear. In one possible branch of the future, the footstep comes. When the data from December 19th is pulled apart in the days that follow, the patterns refuse to flatten. The tiny deviations in the orbit spike where the bolder models predicted. The starfield in that suspicious patch of sky bends again, with a clarity that doesn't go away when you change the processing method or the instrument or the team. The light curve of Atlas, faint as it has become, trembles in ways that now match not just one, but several independent gravitational scenarios involving something heavy that does not glow. Peer-reviewed papers take time. Confirmation takes caution. But slowly, painfully, a consensus might begin to form. Not that we have seen a specific object with perfect clarity, but that something non-luminous has left multiple, consistent fingerprints on the behavior of this comet and on the light behind it. If that happens, if this quiet winter night becomes the first time we catch a local black seed or a dark filament, or a persistent space-time bruise in the act of tugging on something we can measure, then our map of home will change. The solar system will stop looking like a clean family portrait and start looking more like a house with hidden rooms. Gravity, which always felt invisible but trustworthy, will begin to feel invisible and inhabited. In another branch, the universe answers with a different kind of honesty. The data from December 19th lines up. Residuals shrink when late-stage outgassing is handled better. The tail's apparent rings soften and disappear under more careful treatment of background gradients. The suspicious star field, reobserved and reanalyzed with stricter controls, behaves in ways that fall comfortably within noise. The anomalies that led us here do not vanish, but they lose their teeth. They become examples, not of new physics, but of how easily complex, low-signal observations can lead even the most careful minds toward stories the universe never intended to tell. In that outcome, it will be tempting for some to call the night a letdown. No ghosts, no scars, no hidden masses stepping forward to be counted. But that would be missing the point. If the universe chooses on that date to tell us no, you have reached the limit of what this dataset can justify. No, you cannot claim more than what is solid. That answer is still a gift. It tightens the leash on our imaginations, cleans out our methods. It teaches us how not to overreach the next time a strange smudge refuses to act normal. And then there is the third path, the one the universe seems to favor more often than we like to admit. In that path, December 19th gives us neither a clean revelation nor a cleansing silence. It gives us something messier. Maybe the orbit residuals show a bump, but only on some instruments. Maybe the starfield twitches again, but the signal is weaker than before, and one major telescope sees nothing at all. Maybe the tail exhibits a new structure that could be a boundary effect, or could be a subtle change in solar wind, or could be an artifact we don't yet understand. In that world, what really happens on December 19th is that the mystery sheds one skin and grows another. Atlas does not become the comet that settled the argument. It becomes the comet that refuses to vacate the argument. Its name drifts into more and more papers, not as a solved problem, but as a shorthand for an itch, Atlas-like anomalies. Conference talks include phrases like, another Atlas situation. It becomes the story you tell when you want to remind people that the universe often responds to yes or no questions with a long, quiet, perhaps. Somewhere inside all of those futures, a deeper realization waits. It has less to do with exactly what happens on one winter night and more to do with the question we've been asking all along. What will happen on December 19th? Assumes that cosmic truth arrives on human timescales, that the universe schedules its behavior to line up with our calendars, that meaning will be delivered in a single night like a package. But what if December 19th is not the day something happens, but the day we finally look with enough intensity at something that has always been happening? If that is the case, then Atlas stops being a messenger and becomes a flashlight. The comet is not bringing news, it is illuminating structure. The date is not chosen by the cosmos. It is chosen by the geometry of our orbit and our attention finally intersecting the right place at the right moment. What will really happen on December 19th then is not an event. It is a shift, a change in what parts of the sky contain questions for us that we didn't know to ask before. 3I/Atlas, stripped of all its drama, is a lump of ancient ice and rock a few kilometers across. It has no agenda. It has no awareness of Earth, let alone of December. It spent eons in deep cold under a different star, or between stars, shaped by collisions and tides and radiation fields we will never reconstruct. Its decision to cross our vicinity now is not a decision at all, just the unfolding of a trajectory written long ago in a language of gravity and chance. And yet, by refusing to settle cleanly inside our equations, it has already done something rare. It has exposed a seam. For a long time, we told ourselves a comfortable story about our immediate cosmic neighborhood, a star at the center, planets orbiting in mostly stable, mostly predictable paths, belts of rocks here, clouds of ice there, all of it moving through a void that, while not perfectly empty, could mostly be treated as stage rather than actor. Then came the larger corrections. Dark matter, hinting that most of the universe's mass does not shine. Dark energy, suggesting that the cosmos is being driven apart by something we do not understand. Those were grand-scale reckonings. Atlas is a small-scale one. It whispers that maybe even the space inside our neat diagrams is textured. That what we call empty between the planets may hide gradients, clumps, echoes, tiny local architectures that our instruments have not yet been sensitive enough, or our minds not yet willing enough to acknowledge. Whether December 19th brings a clear gravitational whisper or a meticulous wall of silence, that possibility lingers in the air. How incomplete is our reality? Stops sounding like a philosophical question and becomes a practical one. Planetary scientists start to wonder how many subtle, unmodeled influences might have nudged asteroid families over geological times. People who study the long-term stability of orbits ask what it would mean if invisible masses were occasionally wandering through the outskirts of the system, tilting things by fractions of degrees that only matter over millions of years. Instrument builders sketch out detectors that can not only measure brightness and position, but also detect minute distortions in the grid of the sky, like fingers pressing into a sheet. The date itself will recede. Calendars will turn. Future winters will have their own concerns. But the crack atlas opened and our certainty will stay. The idea that we might be living in a neighborhood whose quiet is not the same as emptiness will be difficult to unlearn. Underneath the math and the machinery there is another layer, and it is human. The feeling that creeps in when you consider, seriously, that you have always been sharing space with invisible structures that neither know nor care that you exist. Black seeds that drift through orbits without seeing the planets they perturb. Dark filaments that thread between stars like bones beneath skin. Old scars in spacetime that never bothered to heal because nothing needs healing in a universe that does not feel. It is not disaster movie fear. There are no countdown clocks, no guaranteed impacts, no fiery sky written into this particular story. The dread is quieter than that. It comes from understanding that you are precariously small, briefly self-aware, living on a world whose long-term fate may be influenced by things that will never, in any meaningful sense, be aware of you. The stage you walk on has been built by indifference. The stability you enjoy is, in a very real way, an accident. If 3i/Atlas is carrying a warning, it is this. Not, you are in danger. Not, something is coming. The warning is about perspective. It reminds us how easily we mistake the absence of immediate threat for the presence of cosmic concern. The universe does not keep Earth safe. It simply behaves, and for a little while, those behaviors add up to an environment in which oceans are liquid, air is breathable, and small primates can ask questions about comets. A hidden mass drifting through the outskirts does not swerve to miss us. A warped patch of spacetime does not choose to bend a comet instead of a planet. These things simply follow their own trajectories and leave us to live with the consequences, good, bad, or unnoticed. At the same time, there is one more possibility that has to be kept on the table, no matter how unromantic it feels. After all the attention, all the CPU cycles burned on simulations, all the narrative weight hung on this faint traveler, it might turn out that Atlas's quirks are just that, quirks. The delicate noise of a complicated, fragmenting object observed at the limits of our detectors. The tail ripples might fade into significance levels that no longer survive stricter analysis. The starfield twitch might shrink when biases are corrected and controls tightened. The light curve's apparent heartbeat might dissolve into a pattern our minds once stitched together from random variation. In that world, Atlas does not become less interesting. It becomes interesting in a different way. It becomes a mirror held up to our desire for the universe to speak. It shows us how ready we are to attribute meaning to faint structures, how quickly we lean toward message when we encounter persistent coincidence. It forces us to refine our filters to separate signal from yearning. It leaves behind better pipelines, more disciplined skepticism, a keener awareness of how easy it is to walk off the edge of justified inference and into story. And yet, if some durable core of the anomaly remains, if, years from now, after December 19th has joined countless other forgotten dates, there is still a cluster of behaviors around this comet that refuses to be flattened into conventional explanations, then Atlas will find a different place in our history. It will not sit beside cinematic disasters. It will sit beside infuriatingly precise mismatches that once nudged us into new physics. Beside Mercury's orbit, which would not quite obey Newton. Beside galaxies whose stars orbit too fast for visible matter to hold them. Beside the faint microwave hiss that turned out to be the echo of the Big Bang. In that position, 3i/Atlas becomes less of a spectacle and more of a long-term assignment. A small, relentless question the universe has tucked into our homework, one we can postpone for a while but not ignore forever. It will whisper for as long as people care to listen. Something about your picture of local reality is still wrong. Eventually, the day itself will roll around. December 19th will slip over the curve of the Earth, turning night into morning in some places and afternoon into evening in others. In cities, people will stand in lines, answer messages, get stuck in traffic, make coffee, have arguments, laugh, get tired, and fall asleep. They will live a day. Most of them will never hear the name 3i/Atlas. The sky will look as it has always looked to them, a distant, decorative backdrop. In a few small, quiet rooms, the day will feel different. Someone will sit alone with a screen, watching a graph update in real time, feeling a knot in their chest that they will later describe, inaccurately, as stress. They will see the line jump or not jump, and understand that this tiny motion carries implications the outside world will not notice for months, if ever. Somewhere else, someone will step out of a control room between exposures, stand in the cold outside the dome, feel the sting of the air on their face, and look up at a sky that looks completely unchanged. For a second, they might feel something shift anyway, not in the stars but in their sense of what might be hidden between them. And then it will pass. The comet will continue on its path. Its brightness will drop below even the reach of our best instruments. Atlas will go back to being what it was before we ever noticed it. A cold traveler in a vast dark, carrying its secrets whether we read them or not. Observation schedules will relax. Graphs will be saved, backed up, archived. The night will fertilize papers, arguments, careers. Life for everyone else will go on. What remains is not a crater or a new star in the sky or any visible scar on Earth. What remains is a perspective. The knowledge that an ordinary date in the middle of an ordinary human winter was, for a brief time, aligned with a distant fragment of ice and with whatever unseen influences may or may not have been walking beside it. For a moment, that alignment exposed how thin our understanding still is. It reminded us that we live inside an unfinished explanation. In that sense, what will really happen on December 19th has already begun. It began the moment someone noticed that a smudge on a screen was not where it was supposed to be by a few too many standard deviations. It grew when people decided to take that discomfort seriously, to spend time and energy trying to understand a discrepancy no one else could see. It grew when observatories quietly adjusted their plans. It will continue to grow long after the comet has left, in the form of new instruments built with Atlas's anomalies in mind, new surveys that treat the dying phases of small objects as opportunities rather than just epilogues. New students will hear this story for the first time, not as a tale of near-miss catastrophe, but as an example of how the universe can be both subtle and uncompromising. They will learn that sometimes, the most important thing a comet does is refuse to obey. They will hear about December 19th as a night when we asked the sky a question and did not get the simple answer we thought we were owed. And you, long after this video ends, may find that the date continues to haunt you in a gentle way. You might notice it on a calendar and feel a small, irrational jolt, even in a different year. You might step outside on some random cold night, look up, and remember that once, a small shard of someone else's sky passed through ours and made us wonder how many invisible threads are stitched through the darkness around us. You might feel, underneath the familiar patterns of constellations, a softer presence. Not a looming threat, not a comforting guardian, just the awareness that you are not standing in an empty room. Because you live inside something far more intricate than the diagrams they showed you when you were a child. Around your star and around your world, other travelers are moving. Some bright, some broken, some dark, some not made of matter at all. Some will pass by and leave nothing but a temporary glow. Some will leave traces we do not yet know how to see. Some may, without intending to, tug at the structure of the future we are walking into. Atlas is one of them. It will not be the last. On some winter nights, nothing seems to change in the sky, until you realize the sky has quietly changed what you thought it was. In episode 2, we follow the data trail beyond December 19th itself and ask a harder question. If 3i/Atlas exposed one hidden layer in our own solar system, how many other interstellar visitors have already crossed our sky, leaving unseen fingerprints on the future we're moving toward?